morning friends. Today we are going to discuss about the MCQ question 4. Our next coming exam of this month, January, of unit test and internal exam of chapter 12 atoms. Generally the most of students are feeling not well to calculate the MCQ question. Most of the students directly write down the answer. But here in board exam, not directly, generally the most of the MCQ question asked from the textbook, but not directly asked. Whatever the given in the textbook. The quite minor change is done by the paper setter, so that the answer of this question is different than the given in the textbook. So some numerical value is changed, or the unit of the numerical value change. Suppose that is given in meter, so that is given write down in centimeter. But we feel when we see the question, the same question in our question paper, we know that the answer is this, but that is the wrong answer. For that purpose, do not directly write down the answer of any question in exam. First calculate, and with your calculation, what is the answer you obtain? That is your right answer of given particular MCQ question. Right? In physics, the most of question out of 50, at least the 40 questions are short numerical, while the 8 or 10 question is theoretical, directly asked from the theory of this particular chapter. So keep in mind that always, if we know the answer is this, but one time that is the calculate. And make the surety about the answer of particular question. And read the question carefully with the unit. Numerical value are same, but sometimes the unit are changed of one or two quantity. So your answer is going to change. Clear it? Okay. Now, in chapter 12, the atoms, already we discussed about the theory. Now, what is the first question? An electron in hydrogen atom experiences a transition from n is equal to 6 to n is equal to 3. N is equal to 6 to n is equal to 3. Or we find the frequency of the radiation. That means the electron makes the transition from n is equal to 6 to n is equal to third orbit. Like this way, there is the nucleus 1, 2, 3, 4, 5, and 6. The electron already in 6th orbit make the transition in third orbit, this orbit. So according to the Bohr's hypothesis, the energy difference between these two orbits is radiated by the electron in form of the radiation. We have to find out the frequency of this radiation. So radiation is emitted, because we know that the energy of the electron in larger orbit is more compared to the smaller orbit. Right? Therefore, we know the equation of the wavelength of the radiation, or the wave number of the radiation during the transition in hydrogen atom or the any atom. 1 upon lambda is equal to R into 1 upon n square minus 1 upon m square. So for that purpose, the wave number of radiation, emitted in hydrogen atom is 1 upon lambda is equal to R 1 upon m square minus 1 upon n square. Now keep in mind that here the n is greater than m. N is greater than m. Here the electron make the transition from 6 to 3. So 6 is our n and 3 is our m. Therefore, R into bracket 1 upon 3 square minus 1 upon 6 square. Clear this? Therefore, R into 1 upon 9 minus 1 upon 36. Therefore, we obtain the 1 upon lambda is equal to 27R upon 324. That means the I by 12. I by 12. But we require the frequency, not the wavelength. So we know that. But C is equal to F lambda. C is equal to F lambda. Therefore, 1 upon lambda is equal to C upon F. 1 upon lambda is equal to F upon C. Substitute here. Therefore, F upon C is equal to I by 12. Therefore, frequency of this radiation is RC upon 12. What is the C? C is the velocity of light in vacuum. C is the velocity of light in vacuum. Therefore, frequency F is equal to R C. C is 3 into 10 raised to 8. Substitute the value of R and C. So we directly obtain the answer is 0.2725 into 10 raised to 15 hertz. Here the R is the Rydberg constant. Rydberg constant. Again, an electron in hydrogen atom make a transition from 6th to the 3rd orbit. Find the frequency of the radiation. So here, the wavelength of the radiation emitted in hydrogen atom is 1 upon lambda is equal to R 1 upon m square minus 1 upon n square is the general equation of the wavelength of the radiation emitted during the transition of the electron from one orbit to the other orbit. Here the electron makes the transition from higher orbit to the lower orbit. So here the n is greater than m. The electron makes the transition from 6 to the 3rd orbit. Therefore, our 6 is n and 3rd is m. Therefore, 1 upon lambda is equal to R into 1 upon 3 square minus 1 upon 6 square. So, simplification I into 3 square 1 upon 9 minus 1 upon 36. Therefore, 27 R upon 324. That means the R upon 12. That is the wavelength. But we require the frequency of the radiation emitted. Therefore, C is equal to F lambda. Therefore, 1 upon lambda is equal to F upon C. Because in our equation, the left hand side is 1 upon lambda. Therefore, we substitute the value of 1 upon lambda as F upon C. Therefore, F upon C is equal to R upon 12. Now, F is equal to RC upon 12. What is the R? R is the Rydberg constant. C is the velocity of light in vacuum. Substitute the value and we obtain the frequency of the radiation emitted by the electron make the transition from 6 to the 3rd orbit is 0.2725 into 10 raised to 15 hertz. Clear this? Okay. So this is our answer. Okay, now next question. Calculate the energy required to remove an electron from He plus ion. He plus ion. Now when the electron is released from the any orbit, so if the electron gain the energy equal to its binding energy, when the electron gain the energy equal to its binding energy, so total energy of the electron in that orbit becomes the 0. Now electron is easily removed or becomes the prey from this orbit. For that purpose, the binding energy, equation of binding energy is mz square E is to 4 upon 8 epsilon 0 square n square h square n square h square. So we can add this equation in that form. Me is to 4 upon 8 epsilon 0 square h square into z square upon n square. Now already we discussed in theory the value of this for the electron, mass of electron, charge of electron, epsilon 0 and h is the Planck's constant. So its value is 13.6. So 13.6 z square upon n square. Z square upon n square, that is in electron volt. So that is the binding energy of an electron in nth orbit and any atom. Therefore, we can write the binding energy B is equal to 13.6 into Z square upon N square electron volt. Now, for which ion is given? Here the helium plus ion. Therefore, for He plus ion, what is the value of Z? Z is equal to 2 and N is equal to 1. Therefore, binding energy or the energy required E is equal to 13.6 into 2 square upon 1. That means the 13.6 multiplied by 4 is equal to 54.4 electron volt energy is required. Again, keep in mind the calculate the energy required to remove an electron from He plus ion. Here the number of orbit is not given. That means that we have to remove the electron from the ground state. For this purpose, first, how much energy is required? The energy required is equal to the binding energy of the electron. Therefore, the equation of the binding energy of electron is mz square is to 4 upon 8 epsilon 0 square n square square. Actually, there is the negative, we have to supply externally, therefore that is the positive. Now the value of this term Me is to 4 upon 8 epsilon 0 square square. That is the standard value. As we substitute and simplify, we obtain the 13.6. Now the z square upon n square, that is the depends on the atom and also the electron in particular orbit. Now, therefore, binding energy is 13.6 into z square upon n square electron volt. For helium plus ion, z is equal to 2 and n is equal to 1. Substitute in this, therefore we obtain 54.4 electron volt. Energy is required to remove the electron from He plus ion. Now, next, angular velocity of electron in nth Bohr orbit of hydrogen atom is proportional to the which of the following? Angular velocity of electron in nth Bohr orbit of hydrogen atom is proportional to the which of the following? So we know that from the Bohr's hypothesis, angular momentum MVR is equal to NH upon 2 pi. But we know that V is equal to R omega. We require the angular velocity. Therefore, substitute here M R square omega is equal to NH upon 2 pi. Therefore, omega is equal to NH upon 2 pi into MR square. MR square. That is our equation 1. So from this equation, the most of the students write down the answer. Angular velocity is directly proportional to the n, but that is the wrong. Because here the R is also given. The equation of the R is also depends on the number of orbit. Therefore, we have to also substitute the value of R in terms of the n. But R is equal to n square h square epsilon 0 upon m pi z square. M pi z square. Substitute in 1. Therefore, omega is equal to nh upon 2 pi m. Now square of this and also multiply inversely. Therefore, m square pi square z square e is to 4 upon n is to 4 h is to 4 epsilon 0 square. Now we are interested only about the n. Therefore 1 times n cancel. Therefore n cube is remaining. Therefore bracket 1 upon n cube. Now listen, what is the remaining? 1 times n cancel. Pi cancel. Right? Therefore remaining is h 1 times cancel. Therefore h cube here. So remaining is pi z square. For h atom z is equal to 1. Therefore pi e is to 4. Pi e is to 4 m pi e is to 4 upon 2. Pi m cancel, n cube taken out, h cube epsilon 0 square. All are constant. M pi e to h cube epsilon 0. Therefore omega proportional to the 1 upon n cube. Therefore the angular velocity of an electron in nth Bohr orbit of hydrogen atom is 1 upon n cube. For hydrogen atom z is equal to 1, we consider. Therefore the z square is not written here. Clear this? Okay. Where is it? From Bohr's first hypothesis, mvr is equal to nh upon 2 pi. V is equal to r omega. Therefore m r square omega is equal to nh upon 2 pi. We are interested only for angular velocity. Therefore omega is equal to nh upon 2 pi m r square. That is equation 1. But radius of Bohr, or the Bohr radius of nth orbit r is equal to n square epsilon 0 upon m pi z square. Making the square of r and substituted here, we obtain this. Therefore angular velocity of an electron is directly proportional, is inversely proportional to the n cube. The same next question. Linear velocity of an electron in nth Bohr orbit of hydrogen atom is proportional to which of the following? So we know that mvr is equal to nh upon 2 pi. Therefore v is equal to nh upon 2 pi mr. So most of the students at the answer is velocity is directly proportional to the number of orbit. So there is the law. There is the law. So here we have to substitute the value of r, but r is equal to n square h square epsilon 0 n square h square epsilon 0 upon m pi z square. For hydrogen atom, v is equal to nh upon 2 pi m into inversely multiply m pi z is equal to 1 square upon n square h square epsilon 0. So m pi cancel, 1 times n cancel, h cancel. So remaining is square upon 2 h epsilon 0 into 1 upon n. Now square upon 2 n h epsilon 0, n is taken out. Therefore v proportional to the 1 upon n. V proportional to the 1 upon n. Now in case of an electron in nth Bohr orbit, angular velocity is inversely proportional to the n cube and linear velocity is inversely proportional to the orbit number 1 upon n. Complete? Both are similar. Here we substitute the value of r square and here we substitute the value of r directly. Therefore we obtain the velocity and angular velocities depends how manner with respect to the orbit number. Now the next, for which quantum number of the binding energy of the electron is 0 in hydrogen atom? Now we know that the binding energy is equal to 13.6 Z square upon N square. For H atom, Z is equal to 1. Therefore, binding energy B is equal to 13.6 upon N square. Now listen, the binding energy of an electron is given 0. Therefore, 0 is equal to 13.6 upon N square. So what is the orbit number in which the binding energy of the electron is 0? Therefore, N square is equal to 13.6 divided by 0 is equal to infinite. Therefore, N is equal to infinite. In infinite numbers of orbit, the binding energy of the electron with nucleus is 0, because at infinite distance from the nucleus, the force of attraction exerted on an electron by the nucleus is mostly 0. Therefore, no energy, whether this electron is already free, no any energy is required to remove this electron from the infinite orbit. Right? Okay. So again, for which quantum number of the binding energy of an electron is 0 in hydrogen atom? We know the equation of the binding energy 13.6 into Z square upon N square. For hydrogen atom, Z is equal to 1. Therefore, binding energy is equal to 13.6 upon N square. But here the binding energy is given, that is 0. Therefore, 0 is equal to 13.6 upon N square. We require the quantum number. Therefore, N square upon 13.6 upon 0. Therefore, N square is equal to infinite, and N is also infinite. Thus, in infinite number orbit, the binding energy of an electron is 0. Now next, the ratio of the first three Bohr radii is. What is the ratio of the radius of first three Bohr orbit or the radius? For that purpose, here we have to find out the ratio of first three orbit. First three orbit, that means the quantum number for n is equal to 1, 2, and 3. What is the radius? For that purpose, the equation of the radius of nth orbit R is equal to n square s square epsilon 0 upon m pi z square. M pi z square. So this portion is constant. Therefore, R proportional to the n square. Therefore, the ratio R1 raised to R2 raised to R3 is equal to N1 square raised to N2 square raised to N3 square. First orbit N1 is 1 square. Second orbit 2 square. Third orbit 3 square. Therefore 1 raised to 4 raised to 9. So that is our answer. That is the ratio of the radii of first three Bohr orbit. Where is the numerical? Only we have to keep in mind the equation of the radius of nth orbit. R is equal to n square epsilon 0 upon m pi z square. So remaining quantities are constant. Therefore, R proportional to the n square. Therefore, the ratio of R1, R2, R3, radii of the first three orbit is equal to ratio of its square of quantum number. N1 square, N2 square, N3 square. Quantum number 1, 2, 3, therefore 1 square, 2 square, and 3 square, therefore 1 raised to 4 raised to 9. So this chapter is very easy, only limited number of the equation of the radius of nth orbit, binding energy, that means the total energy. Also the equation of the wavelength, frequency, read by constant, right? So very limited numbers of the equation are in this chapter. So most of the objective question we can calculate from the equation.